Hey everybody! The purpose of this video is to get you some solutions to the Sarah Palin binomial quiz. Just one more little binomial quiz to throw out for the end of the term. I thought it was interesting. That they said that she was a mover and a shaker as far as swaying political elections, and I thought, well, we can actually measure that. I mean, either she does or she doesn't for every single one of them. She has 64 tries to weigh her influence in, so either she does or she doesn't in each one of those. So either she has no predictions whatsoever gotten right, or maybe as many as 64 predictions. So you think about this is kind of like chickens and roosters. You buy 64 birds, you get anywhere from 0 to 64 girls. Same thing. The only thing that changes is the probability of getting something correct. So I set this all up in Excel just because I don't have dist fill on my little TI modeler on the computer. So I just did it in Excel, but of course you can do it in dist fill, which is what I kind of told you to do. But to get you your answers, your average is 31 and your sigma, or your standard deviation, was 4. So assuming that her rate of correctness was, what did I say it was? 48.7. Is that correct? I want to check that again. To make sure that's right. Yep, 48.7. I have the quiz open over here. So what I did was I weighted if you were guessing. So if there were 3 people in a race, she'd have a 1 in 3 chance of guessing the correct answer. And if there were 2 people in a race, you'd have a 1 in 2% chance. So there were a couple of 5, it looks like, 5 3-person races and 59 2-person races. So if she was guessing, she's going to get just below 48.7%. Just below 48.7%, which hopefully makes perfect sense, because if she was guessing at 2 people races, it'd be exactly a coin flip each time. But she has a little bit worse odds because there are a few 3 people races for that. So that's what I gave. If she was guessing, she should have averaged 31 and with a plus or minus of 4. So, and the next thing I had you do, and I can shrink this down so it fits better, I had you guys actually draw a graph of the guess results, and here they are in Excel. Let me squinch it over so it moves. Let me get rid of these boxes. We don't really need that. Oops, that was a little too much to get rid of. I just want to get rid of those. What am I doing? I want to get rid of the... Let me do this. I wonder if I can change the markers to something smaller. There we go. That's better. Close. Thank you very much. So here's the graph, and you can see it's almost a perfect bell shape. It's centered right there on that average of 31. Which is just below that 32. So nice bell curve. I mean, and this is something 244 addresses from almost day one, is the beauty of switching a binomial, even when it's a fairly skewed percentage, although this is not, into a bell curve. So the next thing I asked you, let me call the quiz up again so I can see it. Average standard deviation, there's the graph. Based on your 3 answers, does it appear that guessing 33 correct out of 64 is unusual? Okay, so let me just make sure you understand why we're checking 33. She was claimed to have a positive influence. More than half of the 64 candidates she endorsed won. Okay, more than half. Well, she's right, 33, which is more than the half of 32. So the question is 33 significantly higher than 64? So should we make a big deal about her quote-unquote political weight? Okay, so let's figure it out. She got 33, which means she lives down here on this curve, which is one of the high points of the curve. I mean, it's right there. But that's not a good thing to be if you're trying to prove that you have political weight to throw around. This is the guessing curve, right? This is the guessing curve. If she had political weight to throw around, this curve should be over here. This curve should be over here. She shouldn't be anywhere near this curve. This is the guessing curve. This is the flipping a coin curve. If she was actually influencing things, they should be over here. Now, over here is a relative term. How far over here? Well, I don't really care. I'm going to prove to you I don't think she's on... I'm going to prove to you I think she's on this curve. Remember that standard deviation and average that we calculated earlier? Well, this is roughly bell-shaped data. That means if we were on this curve, most of the data is going to be within 2 standard deviations of mean, which means most of the data is going to be within 23 and 39. 23 and 39. Guess who falls directly within 23 and 39? Sarah Palin at 33, which means she is right there in the middle of where she should be assuming that she is guessing, which means guessing 33 out of 64 is not unusual at all. It's right where you would be if you were flipping a coin. So, in order for me to be convinced that she was actually doing something interesting, my next question is, at least how many endorsements would she have had to have gotten correct in order for me to believe that she was doing better than guessing? Well, if 23 to 39 is considered the range of usual, anything outside of that would be unusual. So if she was getting below 23, I'd think that she was doing worse than guessing. I would think that she was intentionally picking the wrong people. But if she was getting 40 or more, that's when I would say, okay, I'm going to start paying attention to what she's doing now. So that's the answer to the last one. So we answered kind of all 5 of those questions at once here today. Hopefully that made sense to you. I can't prove that Sarah Palin is doing any better than flipping a coin to decide who wins these elections. So I would rephrase, and this is the problem with guys like me reading the news, I would rephrase that Palin throws her political weight behind candidates who deny the reality and risk of global warming. I would say Palin flips her coin to decide who she endorses in the midterm elections. So anyway, just a fun way of utilizing some binomial distributions in an applied sense. Hope you got as much out of it as I did.